Alright, looking at gradient here in this tutorial. Gradient, also known as slope, perhaps, and it's about the steepness of lines. Now, we can have positive gradients. So if you imagine somebody walking up to a hill, reading left to right, as we read in English, going across there, if that person has to walk up the hill, we call that a positive gradient. If when that person walks left to right, they have to go downhill, it's a negative gradient. And you get different lines there, but as long as it's going uphill, it's positive. Downhill, it's negative gradient. So positive and negative, there we are. Doesn't matter where those lines are, positive, negative. So here's some examples. The first one here, if we read left to right, it is a positive. This one here, it's going downhill, so we call it negative. This one is definitely a positive, and this one is a negative. Now, it all seems pretty straightforward there, but it's amazing how common it is for people to do the calculations in gradient and forget to put their positive and negatives. So check the graph first. Is it going uphill? Positive. Is it going downhill? Negative. Sort that out first, and then get into the complicated part of gradients. Okay, we can have steep gradients, so ones that would be really tough to walk up. That's a difficult climb. And we can have gentle gradients. So we say if it's a steep gradient, it would be sort of going up very quickly. And that steepness, we give a value. And we start with this sort of 45 degrees of incline, I guess. This is a gradient of 1. And this means that for every 1 unit I go across, I go 1 unit up. Along 1, up 1. That is a gradient of 1. So the line y equals x, which is this line, that has a gradient of 1. We go across 1, up 1. Along 1, up 1. For every 1 I run, I rise 1. Okay. This blue line also has a gradient of 1, because it's still along 1, up 1, along 1, up 1. And you'll notice that lines with the same gradient, all of these lines have a gradient of 1. And we could change that gradient to make it a gradient of 2, long 1, up 2, long 1, up 2. This line also has a gradient of 2. If lines have the same gradient, they will be parallel. So any lines with a gradient of 2 will be parallel to these lines. Back on that slide, all these lines have a gradient of 1. They are all parallel. They all go in the same direction. Useful to know. This line has a gradient of 0.5. For every 1 I go across, I go up a half. I go up 0.5. And so how do we calculate it? Well, here we go. 3 things to do. On your line, first of all, pick 2 coordinates on the line. I'm going to pick 1 here, and then I'm going to pick 1 here. Let's just make it clear, there and there. Then I'm going to draw a right-angled triangle underneath with those 2 points. Then I'm going to divide the distance it's gone up by the distance it's gone across. So this has gone up 2 units for every 1 it's gone across. So I'm going to do 2 divided by 1, and that is going to give me a gradient of 2. Now there are many, many different formulas for this, but the principle is always the same. We always find 2 points on the line, calculate for those 2 points, how much have I gone up, how much has it risen, how much of a rise is there, for how much across it's gone, how much of a run. How much has the y-coordinate changed? These are the y-coordinates, divided by how much has the x-coordinate changed. And that can be written in this format: the second y-coordinate minus the first y-coordinate, the change in y, divided by the second x-coordinate minus the first x-coordinate. All of these do the same thing. They all calculate gradient by working out how much up have we gone for how much across. We divide the rise by the run. So here's another one. Let's do an example here. Let's pick 2 coordinates on this line. So let's pick that one. Doesn't matter which two I pick here. In fact, let's do this one and this one. Why not? What I would say is pick integer coordinates. Sort of try and find as exact ones as we can. So here we've got -4, -4, -8, and then we've got 2, -2. So draw in my right angle triangle there very badly. 1, 2, 3, 4, 5, 6 units of rise for 6 units of run, or 6 units of up for 6 units across. So this has a gradient of 1. 6 divided by 6 is 1. Let's do some more examples. Here, pick a point, rise of 3, run of 1. 3 divided by 1 is 3. Let's do another example. Here we go, pick a point. This time, I'm going to go, it's gone across 2, but it hasn't risen 2, it's actually dropped by 2. And this is going back to that first thing I said about negative gradients. So this has a negative gradient because it's going downhill. So straight away I'm going to put a minus in there. I know my answer has to have a minus. Now let's do the calculation. If you remember to check for positive and negative, you don't have to be quite so particular on your up divided by across. You can just do the 2 divided by 2. If you want to be particular, this has actually not gone up 2, it's gone down 2. So -2 divided by 2 is -1. This has a gradient of -1. Every 1 we go across, we go down 1. Long 1, down 1. Let's do another one. Another negative gradient, so just put a minus. I know my answer's got to have a negative. For every 1 we go across, we go down 2. So -2 divided by 1 is -2. So my gradient, -2. And here we have a fractional gradient. This time I go across 2 and up 1. So just be careful, up 1, across 2. My gradient is 1/2, or 0.5 if you prefer. Both the same. That is a gradient of 1/2. Here we've got a gradient of up 1, across 3. So we've got a gradient of 1 divided by 3. That's a third. And last one we'll do, nice tricky one. I'm going to add fractions and negative here. But the technique's still the same. Draw that in so it's gone down 2. For every 3 it's gone across. And so we're going to get -2 over 3. Excuse me writing with a mouse. And that is the gradient of that line. So that's gradient.